So just before we join Frank, just a few words about Frank. Frank joined Panduit as an engineer over 14 years ago. He holds 30 patents in copper connectivity and cable design. He has since held other management roles and currently is the product line manager for Panduit's enterprise products. Frank is also active in the TIA TR42.7 standards group, which is developing new standards to support new applications like single pair Ethernet, higher power PoE, 28 AWG patch cords, and field terminable plugs. He is a frequent speaker at conferences such as BIXI on new copper developments. So without further delay, welcome to Frank.
Thank you for the introduction, Barry. Today we'll be taking a deep dive into the topic of single pair Ethernet. But first, just another reminder to stay tuned right at the end of the presentation, as there are two $200 Amazon gift cards to be won as a prize from the sponsors of this webinar, Trident Technology Services. So again, thank you to everyone taking some time out of your day to come hear me discuss a topic like single pair Ethernet. To me, this is a very interesting and exciting technology, right? For many of you on this call, I'm not sure your level of familiarity with single pair Ethernet. Some of you probably have heard of it, maybe some more familiar than others, but it's a technology that does not really exist commercially yet. But it's something that's being very actively worked on really across the boards by a multitude of standards bodies and companies. And really the whole purpose here is to provide sort of this new framework of technology, really focusing on applications in industrial, enterprises and in commercial buildings, and really designed to take a lot of the different systems out there that exist today on, what are effectively proprietary networks, and then put them all in something like a single protocol like Ethernet, just to make everything a lot easier to work with, a lot simpler. And then using the existing companies that support it, right? The existing hardware companies, the existing cabling companies, and then the existing, installers and designers and such as everyone on this call. So that's really the purpose of single pair Ethernet. So what is single pair Ethernet? So one way to look at it is just in terms of what technology platforms survive, right? You want acceptance and focus on that platform. Scalability and adaptability, right? This cabling system, if you think of 4-pair structured cabling, how many different applications has it been used for? How long has it been around for, right? How many things can you run on it, right? People are always finding new applications for it. Economy, anything we do has to make sense from a dollars standpoint, right? We do not want to launch a new technology that is significantly more expensive than something but prior without even adding any benefits to it. And then you look, right, there's a lot of different technologies that have come out into the market that try to promise these things, but then they don't work out, right? They end up failing and just kind of going away before they can ever get adopted. Then there are technologies out there, right? Like power over Ethernet, USB, and HDMI that have gained extreme widespread adoption. And with that, we think single pair Ethernet can really be another technology like that will get that acceptance and focus, that scalability and adaptability, and that economy. So we're very, very excited, at Panduit, at Trident, about the future here with single pair Ethernet. So I would assume most people are familiar with what structured cabling is on this call, but it's always good to have a brief reminder of it, right? So when we talk about single pair Ethernet, we're basically proposing what is it going to be essentially a new type of, or not new, but a modified type of structured cabling. And all it means is that there's structure to the cable, right? There's structure to your cable plant, in that you have these cable runs, say a 4-connector system with a lot of different jacks in between, or the more common 2-connector system where you might run a cable from a switch to a patch panel, going to another patch panel to maybe a server. And both can be common. And the one other way to think of structured cabling is what it's not, right? It's not a home run. It's something we call it, at least in the United States. And what that refers to is just a point-to-point connection between a switch or some device and another device, right? Meaning you're basically running, say, a long patch cable between those two devices. That can often be viewed as, well, that seems simple, right? Why don't people do it? But once you've done that, right, you're very much locking yourself into that cabling design. That cable is only going to be able to ever run between those two locations, and there will not be a lot of flexibility in terms of, you know, future changes. Just, you know, it's not a really good recommended way to go. Another thing to think about with single pair Ethernet, where we're going, is the success of standardization, right? So we're proposing a new standardized interface for this type of technology. And you look, right, the RJ45 began in 1987, and it's covered all these speeds, right? 10 megabits per second, 100 megabits per second, 1 gigabit, 10 gigabits. And there's even work being done on 25 and 40 gigabits over RJ45s. There's over 2 billion RJ45 ports made. It's one of the most successful interfaces ever made. And it's a generic cabling solution. The generic part is very important whenever you talk about structured cabling. And what it means is that when we design structured cabling in the standards bodies, you know, usually there's an application in mind for it, but the structured cabling is again designed to be generic, meaning that we design the cabling so it meets a Cat5e standard, a Cat6 standard, a Cat6a standard, or here a single pair Ethernet standard, so that it's not a 10G base T cable, it's not a 1000 base T cable, it's a Cat6 cable or a 6A cable. And you know what this allows you to do, right, is it gives the cabling some lifespan. It means that you can be confident that devices you can connect over it, right? You can test the cabling system to that standard, and it allows for innovation in that space, meaning that when you have a generic cabling system, right, you know, people can try to adopt new technologies to it. I mean, one thing I know is that, you know, for example, power over Ethernet. You know, power over Ethernet, you know, we had a structured cabling system in place, a generic one, and then they were able to put power over Ethernet over it. There's also technologies like HD base T that run over structured cabling now. And that has nothing to do with base T, really in traditional sense. But because we have this generic standard that's somewhat application focused, but not really, it gives you that flexibility to do stuff like that. And some other advantages just with structured cabling, it's easily scalable and flexible. A well-designed network can be easily upgraded and new areas added. It's easy to accommodate moves, adds, and changes. It reduces downtime. It's simple, it's easy to install. It's future-proof. It's easy to upgrade equipment with standardized interfaces. I mean, one nice thing to always think about, right, is that when it's an RJ45 or a category cable, if you buy a new access point or a new camera and you want to replace the one that's in the ceiling, you don't have to think about whether or not that interface is going to go on that new device you bought. Of course it is. It's an RJ45. So, right, worry about what you want to do, not if your wiring can support it. And finally, safety. I mean, this is a very important thing to always think about, but you know, products designed to industry standards are inherently safer than stuff that's being done, you know, by a single company. And the reason why is, you know, just going to these standards meetings, right? You know, we've got over 30 to 40 companies just within TIA that all look at these devices. And it's, you know, always amazing to me is that, you know, when we're working on, say, a new standard or new, you know, new document, you know, I'll go over it, I'll read it very carefully, and then, you know, I'll have my comments for it. And then, you know, someone else from another company, you know, has their comments for it, and, you know, they'll point out a lot of things I missed, you know, I didn't quite catch. And I was like, wow, that's, you know, very good perspective. And right, so you've just got so many people looking at something and working on it, you know, you just know that that, you know, something designed to standards is just going to be inherently better and inherently safer. And when you start talking about what is, you know, single pair Ethernet and what is it going to do, is that it's really going to be a secure, reliable, and cost-effective way to bring Ethernet to the field device level. So you kind of can see here, right, where you've got this building management system up on top, and then you eventually have all these building control systems, you know, these indoor and outdoor zoning controllers, on these end nodes. When we're talking about single pair Ethernet, it's going to be going to attach to all those different devices in the building. That's what we're focused on with this. And then another area that single pair Ethernet's been looking at, and this is where we believe it's going to come first, is for industrial automation. And again, very similar here, we see it as being a secure, reliable, and cost-effective way to bring Ethernet to the field device level. So we see it as being this really nice technology that allows people to come and utilize Ethernet out to all these different devices that today may or may not be running on Ethernet. They might be running on some very unique and different technologies. And just talking about single pair Ethernet, right? These are all the different devices that we see can run on single pair Ethernet, right? You've got lighting or lighting control even. You know, an area we hear a lot of interest in is actually in the lighting control side, where lighting might be right now, you know, if you're using IP, it could be connected to an RJ45, but in this case, you know, if you still are running a light using traditional power, you could connect a single pair for control. Cameras will be a great solution for it. Sensors, we really think sensors could be one of the biggest markets for this. I often look at sensors and saying, you know, when people try to do a lot of sensor deployments, they run sensors with stuff like batteries. And when you start talking about using batteries for powering sensors, it can often lead to some issues in the future where if you imagine a large building with, say, could end up having thousands of sensors, if every one of those has a battery, you're going to have a lot of battery failures at one time. So we often recommend using wiring to connect a lot of different devices. I know a colleague of mine, he works at Cisco, had once commented to me that he said that if you ever want about 30% of your devices to ever not be working at one time, use batteries for them. So just another point. Building automation control systems, there's just like a thermostat. And so just all these different devices, we really see as having a lot of potential to be using single pair Ethernet. And again, when we start talking about single pair Ethernet, we're talking about two-wire cabling systems, right? And one question I'll sometimes get asked is, for single pair Ethernet, you know, how will it fit in? You know, how is it going to work with RJ45? Well, here's the Panduit World headquarters, located in Tinley Park, Illinois. And you can see that there's actually places in our building being shown up on top where we ran cabling systems next to each other. And I guess let's take a step back here, is we wanted this building to be the most technically advanced building available when we first created it. You know, we wanted to do as much automation as we could. We wanted to really highlight, right, how Panduit's products could be used to enable, you know, the building of the future. And so we tried to wire everything as much as possible with 4-pair cabling systems, with RJ45s, and we used category 6A cable throughout the building. But then there were still systems in that building that we couldn't wire with RJ45s or with 4-pair cabling. And some of these systems, you know, such as our lighting system, such as the building control systems, had to all run using standard 2-wire type applications. And those systems had to then be integrated together. So when we start talking about single pair Ethernet, we're talking about those 2-wire systems that are all being run on separate, you know, different systems, not talking to each other necessarily, or they require extensive, that require extensive integration to work together. And there's a place in our building where you can actually see the 4-pair cable being run next to the 2-wire cable. That's just a picture of it. The blue cables are category 6A product, and the orange wire is just traditional 2-wire type cabling. And when we talk about single pair Ethernet, that's what we're looking for as an application here. We're not talking about really replacing 4-pair cabling that's being run. We're talking about looking at these different 2-wire systems that are being run, and how can we do that in a better, more efficient way using a single pair Ethernet type of solution where all the systems are on the same language. So with that, we're on our first polling question. All right. So the first question was, do you currently get involved much with digital building system integration? And we had about 2/3 of the respondents respond yes, and 1/3 respond no. So thank you for your response. So why single pair Ethernet? So when we start looking at the expectations for commercial buildings and industrial things, a lot of these people are starting to ask, and they want the benefits of this IT evolution, right? They want systems to be optimized, but have security on them. They want predictive maintenance. We've heard of stories of people want to be able to put a sensor, by some production machine, and maybe a vibration sensor. And they know that when this thing starts vibrating a little too much, it needs to be replaced out in production. So they put a vibration sensor there that allows them to predict when they'll be able to, or when they need to do maintenance on it. They want systems where software is upgradable. I mean, these days, if anyone has a smartphone, you take for granted that, some of the apps you might have had on your smartphone are now, 10 years old, and they've been upgraded so many times, it's like you forget that. Whereas, now we're in these buildings where we have maybe sensors and cameras and all these other devices that are 10 years old and have never been upgraded, because you can't upgrade them because there's no real easy way to do the software. We want technology to be connected to the cloud. We want these things to be accessible everywhere. We want to have these converged management layers where you have the different systems that talk to each other, right? And what we see is that the current protocols and network structures are the barriers to innovation. And it's best to adopt IT married to OT's core strength. So what we're basically saying on this is the fact that, if you imagine that you have a room, right? So you want to have a room where when the light comes in, the sensors detect it, the lights dim in the room, and the shades might raise up or down, depending on the light levels. If you can think about it, that could be a lot of different systems that have to all play with each other just to do something simple. You have the light sensors that, are speaking one language. You have the lights themselves that are probably running off of a pretty elaborate proprietary system. You have the shades, and then you have to have something that designs in the intelligence that says, okay, when this sensor sees this, do this. And what we're talking about here is really simplifying the fact that, okay, we want the main challenge to be to write the intelligence behind it, right? We don't want the challenge to be, to take the lighting systems, and start running almost like a decoder to speak the language of the lighting system, to speak the lighting language of the lights, and then get them to all talk to each other. We're really trying to make it just about designing in that functionality. And data. These days, right, data mining and doing things with data is critical to everything, right? People want data. People want having, access to it. And here's just some examples of, Cisco recently estimated that by 2019, IoT devices will be generating more than 500 zettabytes of data per year. It's 250 billion DVDs, 36 million years of video. And it's just, a tremendous amount of data. I mean, you can see the Great Wall there just being another example. And by having these single pair Ethernet solutions, by having all that, you'll have more data than you ever know what to do with. And all this data will be running off of, this one protocol and being able to easily use it. We often see that, people don't really even, once you have all the data, people can be surprised at what you can do with it. You hear countless studies that are published online these days about how people look at some data and then they run some algorithms on it and they're able to peel off these, really good nuggets. And, that could be for, how are people utilizing your building, right? If you think of a commercial office space, where are people coming in? How are they doing it? On a production floor, right? We've talked about how, people might, find new ways to utilize data coming in from the sensors to do predictive maintenance on that machine. Or even if you're in retail, right? Maybe you could see, what parts of the stores do people walk through, right? What do they see? I know that I've, been to some camera companies and, spoken with these individuals. There's cameras out there, right? And software where basically they can tell you how many people walk into a store, how many people walk out of a store. In the US, there's now Amazon stores that are popping up that actually don't even have cashiers. They just basically you walk in, you can walk up, grab an item from the shelf and walk out of the store, and they'll charge you for that item. And all that is done through integration and using data. So data is key. This to me is a very important slide. This kind of shows why we're so big on single pair Ethernet. So if you imagine way back in the day, here are all the different protocols and different ways people were using to communicate, like essentially over the, I don't even know what the right word is, but let's say internet, right? These are all the different ways it went. And that all converged to TCP/IP, right? And that all converged over the RJ45. And think about how great that is, right? I'm sitting here, in my house right now, and I've got a, modem downstairs that's, connected with RJ45s on it. I'm sure I'm connected, remotely to some, data center somewhere that has a bunch of RJ45 cables in it. And it really makes, the fact that, I'm sitting here in the United States talking to everyone, across the Atlantic, and, we're all doing this pretty seamlessly. And the fact that we've been able to do something like that really speaks to some of the simplification we've made on interfaces and protocols. So now you jump today, here's what all the different protocols look like when you start talking about industrial applications, as well as different applications you might see in commercial buildings. And so, this is the same world we've been living in right now, right? Or the same world we used to be living in before we all standardized on what is the RJ45 and the TCP/IP protocols. So with single pair Ethernet, this is what we're effectively proposing here right now, right? Is moving everything from all these disparate technologies, all these different kinds of interfaces, onto something that's standardized, onto something that speaks one language. So that's really the key here, one of the keys here with single pair Ethernet and what we're trying to do with it. It's about power. And so every OT device requires power. A single medium for data and power is preferred. Current battery technology is not scalable. Battery technology is not as reliable as a wired connection. Operational technology devices are critical to production and the health and safety of building occupants. So with single pair Ethernet, it's being designed to accommodate power. It's being designed to be able to transmit some amount of power. And it's kind of variable depending on the length of it, but it's looking to be at least 7 watts. And remember the analogy I shared before, right? Where I said, if you have a large scale infrastructure and you have a lot of sensors deployed, assume at any one point, 30% of those devices are not working. I know from my own personal standpoint, when we moved into our house a long time ago, the house actually had a security system in it. And at one point, my wife and I decided, okay, we've got this security system. Let's figure out how to get it, working in case we ever want to use it. And in that security system, the house came with, it was a wired system. But when the guys came to kind of integrate it and get it back working, they decided, they proposed to install a few wireless sensors around the house. And well, we let them. And this is true, is that at least when I used to travel for work, the security system, with the wireless devices, it comes with batteries on them. And they tell you these batteries will last for at least 5 years. I can tell you right now they don't. And they like to fail at about 2 in the morning when I'm out of town. So I'll wake up when I'm traveling and have a bunch of text messages from my wife, and it would be the security system started beeping. Because that's what it does when the batteries fail at 2 in the morning. The security system just starts beeping at her. And so that's just a wonderful feature. But I think, imagine now that's my house where I maybe have 5 of these devices. Imagine a commercial building with, thousands of them. And we actually looked at it and we found that if you were to have thousands of devices in a building and you would have to replace so many of those batteries per year, you could actually become almost somebody's full-time job to walk around and try to replace all the different batteries on all these different devices, just finding them. Okay, that one's broken, I got to hook it up. When it's a wired device, it doesn't really, the wire is not going to fail, right? The device is going to be what might, end up failing before the wire. So by having that wire there, that single device that can provide data and power, that's very key. And something else we've known too, just with the success of it, is power over Ethernet. Power over Ethernet has been a huge success, and people really see the cost benefits of it, right? It's very simple. Say you want to deploy a camera or a wireless access point, you just run that single RJ45 cable to that device, and now that device has data and power on it. And that is a very key element of what we're seeing with this, and why we think the fact that single pair Ethernet can both do data and power is going to be key for its success. And it's about a standardized interface. And standardized interface from our standpoint at Panduit is just so critical, right? It enables a wide ecosystem of products and ensures a product availability. It eliminates this proprietary and non-compatible interfaces, and it really gives people the confidence to deploy for performance and safety. And you can just see that example over there on the right. Apple loves coming out with their, different interfaces every now and then. But unfortunately, that's not really the way the world works, right? You might have, Apple has their Lightning connector, but then you might have, an HDMI connector. You might have a USB connector. And those other connectors, if you're not in the Apple world, right, and you still want to connect to them, can be a real pain to do it. I mean, you can see this example. It's kind of a crazy one, but, you've got a guy connecting, looks like a few different USB devices, and you can even see the one image there. It looks to be that he's got a he's got a dongle connecting to a dongle, which is connecting to what appears to be an RJ45. And by having that standardized interface, right, if you imagine what might happen is, say you wanted to upgrade all your sensors, right, in a building. You said, okay, these sensors were great, but it's been 5 years and this new sensors out there, all these awesome features that I really want, that I want to deploy. Well, if it's a proprietary interface, imagine the hassle, right? Of you go up to that room, you go up there, you got this new neat sensor, and you look at it and you're like, oh, I can't plug that in to my cabling infrastructure up there. Wow, that's a real pain, right? No, I got to go out and buy, hundreds of dongles or adapters that can now connect this sensor to my existing cable. That's just difficult, right? It doesn't give you confidence. It gives you another failure point. It gives you a lot of other issues, right? But imagine that, similar to the RJ45 today, you have a camera that breaks. You have an access point you want to replace. You have a camera you want to upgrade, right? There's no concern about it. You just basically go out there, as long as the link's fast enough, or as fast as you want, you go out there, you look at it, you take the camera down, you put the new camera in, you plug it in, it works great. That's what we're trying to propose here with single pair Ethernet, is to get people onto that single type of platform where it's upgrading is as simple as connecting, pulling the old stuff out, pulling the new stuff in. And it's about people. And really it's the people, that are on this call, that are listening to me talk right now, is the fact that when deploying a new technology like this, right, there needs to be people that can install it, people that understand it, that know how to do it. And one of the reasons why people like single pair Ethernet, people at Cisco and other companies, is because there's people like you out there that understand how structured cabling works, that know how to pull it, that know how to test it. So that's a really big, exciting element of single pair Ethernet for us, is that we look, out there, and there's, a market of hardware companies working on it. There's there's cable companies like Panduit working on it. And then there's people like you out there that know how to design it, spec it, install it, and maintain it. So that's a really important part of it here, is that when we look at this new technology, we think it is something that could be very useful for everyone out there. And this is just looking at the state of the network. And when you look at it right now, this is for industrial, you can see that industrial Ethernet keeps growing. And it's been really taking advantage over the cooling of field bus deployments. And everyone's really seen that industrial Ethernet, has so many advantages in the industrial space. And we're going to be seeing that in the commercial building space. And this industrial Ethernet, by having single pair out there, is only going to help, spur further growth of it, by making all the industrial components talk with that one language. I mean, going back to industrial, I don't, anyone that's ever familiar with going onto a plant floor or working with a plant, I know from, my experiences at Panduit, it really is the fact that a lot of the systems, especially old industrial systems that are in place, they are a homemade system, right? They're made internally to Panduit, and there's often a small number of people that really know how those systems work, that know how to maintain them. And if that person retires, if that person is sick and there's a problem on the network, it's a real hassle to try to figure out how to get production up and running again. And by having something like Ethernet and having something do it, there's still going to be those people that know how to do it, but the issue won't necessarily be the communication language. The issue will just be getting it up. So, we have seen just so many advantages to moving things onto Ethernet. So how does it work? Here are some of the single pair Ethernet standards going on. And I've highlighted two of them, the ANSI TIA 568.5 standard. That's the one that I'm pretty familiar with. And that's been done specifically around single pair Ethernet work. And then the ANSI TIA 862-B.2, that's in a single pair addendum to intelligent building systems. And you can just see the multitude of different work that's been going on right now within the standards bodies to provide single pair Ethernet. And the way I look at standards, all the stuff on top, that's with the IEEE. And the IEEE is sort of like the, if you want to call it the main group, the driving group, the group that's really in charge of it all. They have the hardware companies, the chip companies, the cabling companies all sit down together and come up with how these things are going to work. And I'll say that really the chip companies and the hardware companies do most of the driving there. When you get down to TIA on the bottom, that's where the cabling companies drive it. And often what we'll do is we'll get some requirements from the IEEE, and they're good requirements, but it's really for the end-to-end link, right? How does it need to perform? What does the equipment see on one end? What does the equipment see on the other end? And what we do in TIA is make that into cabling specifications, right? So what does it mean? How does the connector need to perform? How do the patch cords need to perform? How does the bulk cable need to perform? How do we ensure that when we put it all together that it works? So that's what we do in TIA in 568.5. 862-B.2 also then looks at it from an application standpoint, right? How do we recommend deploying single pair into a building in such a way that it makes sense, that is good to do? This is an example of what single pair Ethernet really looks like today. And I just compared it to 4-pair cabling just to give a perspective. So single pair Ethernet is, or 4-pair goes up to 10 gig. Single pair, we're only talking about 10 megabits per second. But one difference here, right, is that you can see that's at 1,000 meters. Traditional 4-pair cabling with copper goes up to 100 meters. Single pair goes up to 1,000. Power levels on 4-pair, these days with the new PoE standards, can go up to 71 watts. Power levels on single pair are anywhere between 7 watts and up to 52 watts. It depends on the cable length. So at 1,000 meters, you're probably only going to get around 7 watts. When you're at 100 meters, you're going to be a lot closer to that 52. And connector type, everyone knows the RJ45. With single pair Ethernet, we have something we're calling it roughly the modified LC. So LC has been one of the most also deployed connector technologies out there in the market. What we're doing here is a slightly modified version of it designed for copper. And so it's a very familiar connector type and should work well. And RU density. With an RJ45, you can get about 48 points in one rack unit. With single pair Ethernet, it's about twice as dense. You can probably get up to about 96 ports in one RU. And hopefully people are familiar with the image on the bottom. That is a quarter and a dime, just trying to show how small a single pair Ethernet is. It's a lot smaller than a traditional RJ45. And that was done very intentionally. When we start talking about what is the application for this, it is sensors, right? Small sensors. Small sensors want a small device to be plugged into it. I know these days with laptops, right? Laptops, the RJ45 port is almost as wide as the whole thickness of the laptop, if there still is one. With single pair Ethernet, it's purposely being designed to be much, much smaller to really fit in where we see the application space for it. You can just see here's another view for it. The main IEEE we're looking at is 802.3CG, which defines 10 megabits per second Ethernet over single balanced pair. So again, remember, it's single pair, it's one pair. It's designed for building industrial automation. Key attributes, power and data. There's actually reaches of 15 meters and up to 1,000. Another thing they're starting to look at right now is also something called multi-drop. So most of the time here I've been referring to the point-to-point connections, right? You have one port on a switch going to one port on a camera, say. But anyone familiar with building automation today knows that a lot of these things don't work that way, right? You might have one port somewhere going over some sort of bus to multi-ports somewhere else, right? So you might have, right, one port going to 10 or 20 ports. And the initial standard is 802.3CG is the point-to-point. They're also starting to look at multi-drop technology on this. So this would be the first Ethernet system to ever use multi-drop. So it's kind of a neat way, a neat thing that they're looking at with single pair to even further the use of it. This just shows the single pair connectors. There's a few others being considered, but right now TIA has officially adopted the connector you see up on the top there. A few things to note on this connector. You can see that it has this indentation in the connector on the top left. And that indentation ensures that it will not fit into an LC fiber port. So while it looks a lot like an LC fiber, we do not want someone plugging this in to a fiber port. It will damage the fibers or it could cause other issues. So you cannot get a single pair LC connector into a fiber LC port. The picture on the right, where you see that little black thing come out and you can see those little gold objects in between, that's just to highlight, because the common question we get asked is, can you field terminate this? How will this work? Will it be factory terminated? Those are installation displacement contacts, or IDCs. So single pair Ethernet will be field terminable. It will be able to be installed in any application. And there's going to be available in 2 flavors. What we're showing up on the top would be more like an IP20 version of it. An IP20 just means it's really not for harsh environments, but designed for a typical indoor use for a commercial building. But then will also be an IP67 version of single pair available as well. And that's being shown on the bottom there. And IP67 is designed for industrial applications and is resistant to things like water, dust, and other types of debris to provide a connection that's sealed and nothing can get in there. How is single pair Ethernet going to work? Well, it's going to be 18 to 26 gauge, unshielded or shielded. And we expect there to be kind of two common use cases for single pair Ethernet, essentially when it launches. And again, this is all subject to change, but our understanding is that we think that in industrial, it is going to be 18 gauge shielded cable. And the cable will be constructed to have that 1,000-meter reach optimized. And it'll be shielded to perform in the E2, E3 environment. So really, you know, it makes sense, right? The industrial cable is going to be really optimized for long reaches that you might see in, you know, some of these large factories or warehouses or other areas. And it's going to be shielded to avoid the sort of noise you might see in a plant floor, whether it's noise, you know, coming out of, you know, say, you know, different motors or types of environments. On the enterprise side, we think that it's going to be 23 gauge unshielded. And we think it's going to be optimized to be around a 400 meter link distance. So on the enterprise side, you know, you could still deploy at that 1,000-meter reach if you use an 18 gauge cable. But, you know, we've looked at it and we think that most enterprise applications would be captured in that 400 meter link distance. And, you know, there's some debate right now is, you know, because current building automation systems are predominantly shielded cables, whereas, you know, traditional RJ45 is unshielded. And, you know, it depends on who you talk to, who they think it's going to be shielded or unshielded. And for right now, I'm saying most of the cable will be unshielded, just from the standpoint that the people that we view as installing this, or I view as being a dominant installer of single pair Ethernet, are going to be the people today that are, you know, used to deploying unshielded cables within an enterprise. Now, granted, within Europe, shielded is more common. So perhaps within the European region, a shielded variant will be more common. So remains to be seen. And we would expect the flame ratings here to be typical European flame ratings. So you'd be looking at, you know, Euroclass, CCA, DCA, and, you know, in other regions that are not on the Euroclass system, they would be predominantly low smoke. So cable reuse, another topic on this is single pair is trying to take advantage of existing cables. So anytime hardware companies look at trying to deploy a new system, they want to ensure that the cable can be reused. So basically, is there cable in the building so they can just basically take it, hook it up to their system, and redo it without pulling new cable? There may be possible to reuse cable when single pair Ethernet comes out, but some of that cable is really, really old and is really not designed to do what single pair Ethernet is proposing. Single pair Ethernet is structured. It's, you know, a highly engineered solution. So while things may be compatible, you know, we're basically just saying that this is likely going to require a predominantly new cable. And if someone does want to reuse old cable, use a field tester to really determine if that cable is viable for single pair Ethernet. And here's just the general topologies. There's two different terminologies being used here. There's the 10 base -T1L link, and that is the 1,000-meter point-to-point link where you can actually have up to 10 connectors between it. Current RJ45 says only 4. We're not really seeing a huge need for 10 connectors in commercial buildings, but in other areas it might be needed. And then the 10 base T1S is the multi-drop technology I referred to, where you'd have a switch that would be connected to multiple nodes as being shown there. And again, we really see both of these technologies as gaining a lot of different adoption and a lot of different use cases. You know, really the first one, this is something, you know, that is pretty new for this length. And this would be used in, you know, for example, I could easily see this having a lot of applications, say running to some cameras. Whereas in this one here, this would be a good drop-in for existing building automation type systems that are already using multi-drop technology. So again, it would be very familiar to, you know, the people that design the hardware systems for building automation and, it would be very simple for them to then adopt single pair Ethernet using this technology. So great. Hopefully you're all now excited about single pair Ethernet. When can I buy it? Still not for a little while. You know, this is a forward-looking type of technology, and we expect industrial adoption to be starting in sometime next year, 2022. People in industrial probably need this more than people in building automation. You know, when you talk to some people, you know, on the industrial space and they're looking at it, you know, right off the bat, they say, oh, wow, I can really simplify my control panel from like 15, you know, different wiring systems down to down to this, right? They're instantly excited. Enterprise adoption, we're expecting in about 2022, 2023. Again, all remains to be seen. Obviously, you know, wasn't expecting to be in a global pandemic right now. So these things can always change, but we do think that this technology will start coming out within about, I'd say, a year and a half or so, within 2022. You'll start seeing it, you know, becoming much, much more common. Because again, for all the features and benefits that we've really been shown here, right? That it really simplifies things, and it puts things over a standard interface, and it really would make, you know, technologies being seen like even in industrial side, on the building side, you know, to have a technology like single pair Ethernet, in our view, really enables a lot more innovation and design in all these different spaces, because now you have a single structured, standardized cabling infrastructure that could be the foundation for everything else that's being done on it. So time for the second polling question. Do you see single pair Ethernet, when widely deployed, will increase the prevalence of smart buildings and the Internet of Things? All right, and wow, 94% of respondents said yes. So thank you. So again, thank you for everyone's time on this call today. I hope you found this call informative and really exciting for the future of, you know, the cabling industry here, with the opportunity single pair presents relative to both industrial and building automation systems, or, you know, really anything else in a commercial building. So with that, I'll turn it back over to Barry.
Thanks, Frank. That was really great. And as somebody who started off in kind of the HVAC world and then moved into other services in buildings, it's really great to see this happening, and getting rid of the spaghetti of wires that we've been used to on projects up to now. So what I'm going to do is get through as many questions as I can. I hope that at some point we'll put up a questionnaire, a quick questionnaire for you on the presentation. If you could just fill that in for us. But anyway, get into questions. So I'll get through as many of these as I can. If I don't get to yours, I'm sure Frank, it'd be okay if Frank's email is there. So please email Frank. I'm sure that's okay, Frank. Yeah.
Yeah, no problem.
Okay. First one, this is a good question. Can this cable be installed on the same path as 4-pair?
Yeah, no, that is a good question. This cabling will be installable on the same path as 4-pair. I mean, it's absolutely intended to be the case here. They should not interfere with each other.
Okay. So there was another question I noticed a little while ago is about balance. How can you balance a single pair cable? But I guess that's a balance from the single pair to the 4-pair, is it?
Well, I mean, I would assume if you're referring to, you know, what does balanced structured cabling means, the balance actually typically refers to the fact it's a differential pair. So when you have a pair, right, you have two signals being sent that are supposed to be opposite each other, and then they add up together to be 0, and that's what a differential pair is. and that's what makes it balanced. In the single pair, because you only have a single pair, it's still a pair, and so you're still transmitting a differential signal down that pair, which is assumed to be balanced, and hence how you could have a balanced single pair cabling system.
Right. And then are you seeing any progress in EN or IEC as a standards for SPE?
Yes. You know, IEC actually, so the connector I showed you, I think it is, oh, I can't think of the name of it. So the LC connector I showed on it has an official IEC specification for it. So there's absolutely been work in the IEC and the different more European focused standards.
Okay. Another question, when you're daisy chaining, so if you've got a limit on length of, say, if it's 1,000 meters or 400 meters, I guess that's over the total length of the daisy chain, is it?
Yes, so when we're showing that length over the 10 connectors, we're assuming that there's no active devices in the system. So just why I just want to be careful on the term daisy chaining. What you're basically seeing is, you know, one active device, and then 1,000 meters away could be another active device, and then you have 10 passive connectors in between. So that's how it's being shown to work. So you're really looking at, you know, a true, you know, 1,000-meter link without requiring any sort of power or active components in the middle.
Okay. And then there's a few questions related to uptake. One question is asked about whether there's any countries where this is being installed, or are there any particular sites where you've actually seen this installed? And do you think that single pair is eventually going to shrink the market for four pair, or is it going to be on top of the market for four pair?
No, so you know, relative to seeing it installed, is that, you know, right now, no, I mean, I've given, you know, you kind of saw the timeline I put up there in the presentation, is that this is something, again, that's intended to be a little bit forward looking here and showing where the industry is going with technologies like this. So right now, we're not seeing really, you know, any true, you know, deployment of this. I mean, you know, really even from a company like Panduit, you know, we've been working on single pair for quite some time, but, you know, still are not really commercially selling it. You know, relative to its impact on the four pair market, that is a common question we get asked, is we really don't see it having any impact on it. We see them being complementary technologies. You know, if you recall the one example I gave on the Panduit World Headquarters, you know, there's about 600,000 feet of four pair cabling, 500,000 feet of single pair cabling. And what we see with this is that the two technologies, you know, really should coexist together and really, you know, be, you know, mutually beneficial to one another, in that they're all running, you know, they're all standardized cabling systems, you know, running Ethernet, and each being really optimized, you know, for what they need. So, you know, right, four pair is, you know, faster data rates, you know, higher power. Single pair is lower data rates, lower power, you know, maybe, you know, longer reaches, and, you know, wanting that smaller interface. So